Okay, today we're going to go through the test review for the chapter 1 to 3 test. And we're going to start with question number 1. It says 7y minus 14x equals 42. And our job in this problem is to solve for y. So the first thing I recognize is that this is the only y in the problem. So my job is to peel all the layers off that are around it. And I always start with the simplest types of math. And the simplest math is addition and subtraction. I notice on this side I have a minus 14x, so to get rid of that I would add 14x. That's simple math. Now 14x doesn't actually combine with 42, but here the negative 14x and the 14x make what we call a zero pair. They cancel out. But we end up with 7y on the left equals, and you can write 42 plus 14x or 14x plus 42. Typically we write them in this slope-intercept form. That's how it looks right now, but if you wrote 42 plus 14x, it would not be wrong. And then when I divide by 7, it's important that I divide each piece by 7. Technically it is right to write 14x plus 42 all divided by 7, but because these actually do divide by 7, it's preferential that I actually do the division. 14 divided by 7 is 2x, and that's plus 6. And there's the answer to question number 1. Question number 2 still has the same instructions. It says to solve for y. The issue here is that instead of having a y that's easy to isolate, we actually have two y's. There's a y here and a y here. And so the first thing we want to do is try to find a way to get them on the same side of the equal sign. Let's start with that step. And so to do that, I think it'd be pretty easy to just add 10y to both sides. That's going to give me xy plus 10y equals 22 as those two cancel. Now comes the issue. I can't combine xy and 10y because the first term has x, the second term doesn't. But because both of them have a y, I can factor out the y. Think about distribution in reverse. Okay? So for instance, if there was a y on the outside of the parentheses and I wanted to distribute inward, what would have to exist in this parentheses? If I think about taking the y off there, I'd be left with an x, and I'd be left with plus 10. If you were to think about going back into the parentheses, it would recreate xy plus 10y. So that tells me I haven't done anything wrong, and that equals 22. All I have left is to recognize that this is a multiplication problem, and so if I divide by x plus 10, something divided by itself is 1, so that's gone. But to do that, I have to do it here as well. So now my answer would be y equals 22 over x plus 10. Okay, so there's two different types. One where there's just one y in the problem, and one where there's multiple y's in the problem. And we have to get them on the same side and factor them out. The second question talks about building a formula off of an xy table. Now this xy table has 2, 3, 4, and so on for the x's. On the y's, it's 34, 28, and 22. So the first thing I want to look at is what's the pattern as I go this way. I'm noticing the numbers are getting smaller, and if I look real close and I think about it, it looks like I'm subtracting 6 each time as I go from one term to the next. So that tells me, when I think about y equals mx plus b, that negative 6 would be my slope. It's the amount I change. So y equals negative 6x. But the problem is I don't know what b is. You have to remember that b is the value of y when x equals 0. So I need to figure out what happens when x is 0. Now on the test there may not be room to do this, but I'm going to squeeze these in anyway, because I want my x's to go all the way back to 0. If subtracting 6 moves me to the right, then to go this other way I would have to add 6, making this be 40, and again adding 6 to make 46. So that tells me I need to add 46. So you have the slope value, and then you have the number that your value is when x is 0. So that was question number 3. Question number 4 is a word problem. I'm going to read it, and then we'll just go from there. It says you want to hang 6 posters on a 12-foot wall. So I'm going to stop right there, and I'm going to draw a picture. This is question number 4. 6 posters. 1, 2, 3, 4, 5, 6 posters. This is a 12-foot wall. Okay. It says with the same size gaps between the posters and on the edges of the wall. So that means we want all of these gaps here to be the same size. All of them, including the edges here. So we don't know how big that is. We're going to call that X. Okay. However big that gap should be. We want it to be the same the whole way. It also says that each poster is 10 inches wide. Okay. How much distance would be between each poster? So these are 10 inches. 10 inches, 10 inches, 10 inches, 10 inches, 10 inches, and 10 inches. So one of the first problems I noticed with this is that I've got feet here, but inches there. So I'm going to change the 12 feet into inches. It's 144 inches. That's 12 times 12. 12 inches in a foot times 12 feet. It's 144 inches. That's just a secondary thing. I don't think that happens in the other problem that's actually on the test, but you might have to convert units if they don't match. At any rate, each poster is 10 inches wide, and now we want to figure out how big this gap is. Well, how many posters do I have? I've got 1, 2, 3, 4, 5, 6. That's 60 inches, right? Because there's 10 inches each. So I'm just going to subtract 60 inches. I'm going to write out here, this is the posters. Okay, so I'm subtracting the posters. That leaves me with 84 inches. The next question is, how many gaps do I have to fill? There's 1, 2, 3, 4, 5, 6, 7. And so that means this 84 needs to be split 7 ways. So I divide it by 7. It goes in there once and 12. So it ends up being 12 inches or 1 foot between each poster and on the edges of the wall. Now, there is another way to do this without being quite as this is a pretty simplified approach to the question, which is great. But another way to build the problem would be to say that I have 7 X's plus 60 inches of poster, and that equals 144. If you look at the 2 steps we did, we would minus 60. That would again give us 84 equals 7x, and the last step would be to divide by 7. So we get the same answer either way, but there is more than one way to do the problem. Okay, let's go ahead and look at question number 5. There's a set of data. It's -3, -6, -1, 0, 4, 2, 4, 3, and 6, 9. And the question is this a function, yes or no? And you have to explain it. I'm going to say no because the x value or input or domain value, however you want to put that, all right, domain value, you can also just use x there, or the word input. Any of those 3 is interchangeable in this case because the domain value of 4 gives more than one range value, but range can be switched to be y or output. This is a standard answer. The only thing you'd actually have to change is if it was a different number than 4 that was the x, then you'd have to switch which one. But you see how 4 gets used twice? That's indicating to me I don't know what the answer is when I use 4 as my x value. I'm getting more than one answer. Okay. All right, so we move on. Looking at question number 6, it's asking us the same question about what we end up calling a sine curve. Looks something like that. And the question is this a function? The rule is that if we take a vertical line and we move that vertical line around, do we ever touch the curve more than once? The answer is no. It's always only going to touch the curve one time at any given spot. Now right here I obviously did a bad job of drawing it, so exclude that. But generally speaking, no, we're not going to ever touch the curve more than once, which means yes, it is a function. It passes what we call the vertical line test. All right, so we move on. We're going to keep cruising. 7, we start into graphing. And so on question number 7, we have y equals negative absolute value of x plus 4 minus 2. Now, if you remember the formula, y equals a x minus h plus k, you remember that you always switch the one that's with x and you leave the other one alone. What we're looking for to start with is the vertex. And so in this problem, we're going to say that the vertex exists at the opposite of what's grouped with x. Well, this is a plus 4, so I'm going to use minus 4. And this is a minus 2, and it says to leave it the way it is. I'm going to take minus 2. That means I go over 1, 2, 3, 4, down 1, 2, put a dot. And then from there, I'm going to use the number that's in front of the absolute value to determine the slope. Here, the slope would equal negative 1. That means on the right-hand side, I'm going to come down 1 and over 1 to create this side of the curve. And then I would mimic that to the left to create the left side of the curve. So there's my graph. It is important that you state the vertex. But if you were there the day of the test and you were having a hard time getting it graphed right, you can go to y equals, start with a negative, because that's how it starts. The absolute value function is actually in the F2 function, so we're going to hit alpha and window. That pulls up the ABS, the absolute value. Now we're going to have x plus 4 outside the absolute value minus 2. If I go to the graph of this, that looks an awful lot like my graph. If I want to know that vertex for sure, I can kind of tell it's over 4. It looks like it might be down 2. Let's look at the table. Go to negative 4. Sure enough, right here, negative 4 does make negative 2, so that is a good point. But also look at these numbers. Do you see the negative 3, negative 4, negative 5? Those numbers are getting smaller. Negative 3, negative 4, negative 5. Again, we see the slope going down away from that. So I think we're pretty confident that that's the graph. When we look at question 8, we're being asked to go backwards. Okay, there's a graph on question 8. It's 1, 2, 3, 4, 5. I think there's a point right here, and then it goes through there, and it goes through there. And we're being asked to write the equation. So the first thing we want to identify is the vertex, which is 3, negative 1. Okay, because that's where this point is right here. Now we remember it has this format, y equals a, absolute value x minus h plus k. So first thing I might want to look for is the slope. Well, I notice this graph goes up 1 over 1 on the right hand side. So that tells me the slope is 1. So I can say y equals the absolute value of x. Now I have to figure out, what am I subtracting? Well, this is h, and so when I write x minus h, I want to write x minus 3. Notice that the sign switch has occurred. Okay, and I can write plus negative 1 or just write minus 1, which is the preferred method. All you're really looking for is the equation that you would use to graph this. Now, if I graph this in my calculator, it had better look like the one on my screen. If it's in the wrong spot, so say for instance, I go and I write, let's get rid of the negative. Let's say that I hadn't switched the sign. Let's say I left it as plus 3 and minus 1. So this is the wrong graph. But when I graph it, I would notice this does not look the same. It looks like it should be over here. It's supposed to be over here. So maybe something's wrong with the 3. I'll go back there. I'm going to put that minus. Again, problem solving, guys. If something isn't working quite right, can you problem solve it? That looks a lot better for the graph that I hand drew, or the graph that was over here. So I like that a lot better. Okay, number 9. 9, 10, 11, 12, we're going to start getting into systems of equations and solving them. These are still some graphing questions. For number 9, we've got y equals 2x minus 4 and y equals negative 4x plus 8. So in theory, these are all graphable by hand, but I also understand if you have a little hesitation in that. 2, 3, 4, 5, 6, 7, 8, and down 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. If I were to actually try to graph these just by hand, this one starts at negative 4, and it goes up 2 over 1, up 2 over 1, and I would connect the line through there, right? And that's fine. There's absolutely zero wrong with that. In fact, I think that's faster than graphing it in the calculator. However, I know some of you are going to want to do it with the calculator. So I'm going to show you the final step here. I go up to 8. I'm going to come down 4 over 1. I'm going to go 1. I was up too far. 1, 2, 3, 4, 5, 6, 7, 8. No, that's right. 8 down 1, 2, 3, 4. There we go. Over 1. And then I'm going to go down 4 more and over 1. It turns out that it's right there. The intersection's at 2, 0. Now I do have to have the two lines drawn through there so they look appropriately, and then my answer is 2, 0. Now what if I want to use a graphing calculator because I just don't want to make mistakes and I'm really concerned about the computation or how I would graph by hand? So I'm going to do it in the calculator real quick. We said it was 2x minus 4 and a negative 4x plus 8. And if I go ahead and graph those, do they look similar to the graph that I created? Yes. Does it look like they're crossing at 2, 0? Yes. To check, I can go to the table, which is the second function of graph, go to when x is 2, and you notice you have a 0, 0. That tells me 2, 0 is a point on both lines, meaning it's the solution. The other option is if I'm looking at the graph, I press second and trace because I want to do a calculate. And I'm going to calculate number 5, the intersect. And I'm just going to press enter 3 times so it can go through the process and comes up with 2, 0. There's multiple ways to get your answers here on these graphs. Okay. Question number 10. Similar type of an approach. 2x plus y equals 2, and y plus 1 equals x. So the problem with graphing these in the calculator is that they're not in y equals form, so I have to make that happen. I'm going to minus 2x minus 2x. Y is now alone, right? Right here. I can graph that, and here I'd have to minus 1 from both sides. And so now I have y equals x minus 1. So I can go back to my calculator. Again, I could graph these by hand with zero problem, or I can graph them in the calculator. Because the calculator is the one that we'd be more likely to make mistakes with, as far as if you mistype something or something silly, you need to know the whole process. So I'm just going to continue to use that process. If I graph it here, looks like I'm getting a solution at 1, 0, I'm guessing. Second table, sure enough, 1, 0, 0. That tells me at 1, 0. If I do second trace, 5, enter 3 times, the intersection's at 1, 0. So I didn't actually plot any points yet. I need to do that now. I know that at 1, 0, I'm supposed to have my intersection. So I'm going to come in here, put a dot right there. I need to graph the other lines though. This isn't very hard. If I want to graph the other information, I'm just going to go to the table. And if you look at like 2, one of them's at 2, negative 2. So we went to 2 and to negative 2. There's a point. And then if I went to the calculator again, 2, 1 works for the other one. So 2, 1 works for the other one. That should be enough for me to real quickly come through this way and come through this way, and I have a representative graph. The table just gives you all the numbers you'd ever need. So 11 and 12, we're allowed to solve by substitution or elimination. No, there's not necessarily only one way to do it. There is a preferred or a setup. So I'm gonna do one each way, just because I think it's important that you see both options. So 5x plus 4y equals 32. All right, so what I see here is I see a y that I could get alone. All I have to do is add 3x. So I'm going to add 3x, and now I have what y equals. This is called substitution. That information is going to go in the other equation for y. 5x plus 4 times negative 9 plus 3x equals 32. I now need to distribute. I get 5x minus 36 plus 12x equals 32. If I add 36, and I'm going to combine these two, I'll get 17x equals 68. And if you divide by 17, x is equal to 4. Now to find my y, I need to plug this in up there, because I know that y equals negative 9 plus 3 times x, which is 4. 3 times 4 is 12. Negative 9 plus 12, y equals 3. So my answer would be 4, 3. Now, could I have done elimination? Yes. And I'm going to show you what elimination looks like on 12. So you can use either of these methods and not have any hesitation with what you're doing there. Okay, so negative 4x plus 9y equals 9, and x minus 3y equals negative 6. So this problem, I could also try to do substitution by getting this x alone. All I have to do is add 3y, plug that information in where x is, and do the same process. But if I times the bottom equation by 4 or 3, either one, I could get rid of the 9, or I could get rid of the y's, or I could get rid of the x's. I chose x's just because that's what I picked. I'm going to have 4x minus 12y equals negative 24. And the first equation I'm leaving alone. Negative 4x plus 9y equals 9. When I combine my like terms, the x's cancel. I get negative 3y equals negative 15. So y would equal 5. Now to find the x value, I need to plug that in. And I like this second equation. It says x minus 3 times y, which is 5, equals negative 6. Well, this is a negative 15, so x minus 15 equals negative 6. So we add 15, x equals 9. So my answer to this question is 9, 5. If you want to use this method on question 11, feel free to. If you want to use the method you used on question 11 on question 12, feel free to. It doesn't make any difference in the way you do the problem. You might find substitution is harder sometimes, but generally speaking, on the test, it's probably going to be available to you either way. Question number 13 is the doozy. It's the big one that has all of our equations, lots of work. So it's 4x minus y plus 3z equals 13. That's equation number 1. Equation number 2 is x plus y plus z equals 2. And equation number 3 is x plus 3y minus 2z equals negative 17. Alright, so I want to try to find a way to eliminate some variables. And you might see some reasons to get rid of x, some reasons to get rid of y, some reasons to get rid of z. But when I look at this right here, a negative y and a positive y, that's a gimme. It's just going to happen right away. So I'm going to come over here, do equation 1 and equation 2. I don't have to change anything to get the y's to cancel, so I'm going to leave it just like it is. 3z equals 13, and down here I have x plus y plus z equals 2. My x's combine to make 5x. The y's cancel. I get 4z equals 15. It's important that I don't change anything now. I just eliminated y. So when I come over to do two equations now, I need to still change and get rid of y. So if I look at equation 1 and equation 3, I think that will be a good combination for me. 1 and 3. Equation number 1 has a negative y. To cancel with a 3y, it needs to be a negative 3y. So I'm going to times by 3. That makes 12x minus 3y plus 9z equals 39. Down here for line 3, I'm not changing it. It's x plus 3y minus 2z equals negative 17. Here I'm going to get 13x. The y's cancel again. Plus 7z equals 22. I'm going to call this, sorry, this was equation number 4 that I created, and this is equation number 5. I now want to squish 4 and 5 together and cancel one of them. I'm looking at them, and I think z is probably my best bet. I can make 4 and 7 turn into 28. So equation number 4 needs to multiply by 7, making it 35x plus 28z equals 70, and 35 is 105. But equation number 5 needs a negative 28x, so I'm going to times by negative 4. Okay, so thinking about negative 4 times that equation 5 would be negative 52x minus 28z equals negative 88. I'm telling you right now, I sure hope this doesn't mess up and blow up in my face, but I'm going to grab my calculator and hopefully all the numbers are working for me. I've got a 35 and I've got to subtract 52 because it's negative 52. That's a negative 17x. My z's cancel, and 105 minus 88, sure enough, is 17. I divide by negative 17, and x is equal to negative 1. Now I've got to find a way to find z and y. If I take this negative 1 and plug it in right there, I should be able to solve for z. So 13 times negative 1 plus 7z equals 22. This is really a negative 13, so I'm going to add 13 to both sides. These should then cancel, leaving me with 7z equals 35, meaning that z would equal 5 when you divide by 7. Okay, so now I know x, I know z, I need to find y, and I like equation number 2 because they're all singles. There's no multiplication to do. So x is negative 1 plus y, which I don't know, plus z, which is 5, should equal 2. The negative 1 and the 5 turn out to be 4, so I'm going to minus 4 from both sides. I'm left with y equals negative 2. So my answer would be negative 1, negative 2, and 5. And that's it. All we have left is the bonus question. Now the bonus question is pretty straightforward, to be honest, if you just kind of read through the question. It says you and a friend go out to Fiesta for lunch. You order 3 soft tacos, so I'm thinking 3T for 3 tacos. And so we're going to go plus 3 burritos. And you end up having to pay $11.25. Your friend goes with you and gets a $10 bill when he buys 4 tacos and 2 burritos. You might be thinking, hey, I got ripped off. I got 6 things, he got 6 things, and he got to save $1.25. So what we're going to do here is we want to try and use either elimination or substitution. Substitution will be harder on a question like this, typically, but it is possible. I'd probably go after this B, try to isolate it, but elimination is not bad either. I do have to multiply by a number to get these to cancel. I think I'll multiply the top line by 2 to make this a 6. That makes 6t plus 6b equals 22.5. And down here I'm going to times by negative 3. That makes negative 12t minus 6b. And that right there, that's the payoff. I wanted the b's to be opposite. equals negative 30. This turns out to be negative 6t, those cancel, equals negative 7.5. When you divide by negative 6, grab a calculator, a negative 7.5 divided by negative 6 is $1.25. So a taco is $1.25. To find out what it costs for a burrito, I'm going to plug that into one of these equations. Let's do this bottom one here. So 4 times 1.25 plus 2b equals 10. Well, 4 times 1 1/4 turns out to be 5. So I can minus 5, minus 5. I get 2b equals 5. Divide by 2, b equals 250. So now I know the cost of a burrito and the cost of a taco. And that is the end of the review. Good luck. Come in with your questions, and let's get this first test nailed down. Thanks.